Okay, as a quick poll, this is what you should be doing to get started. Based on our lesson from yesterday, we should be able to model this using some algebra tiles, or at least know how to manipulate this so that we can simplify it without. So 10x minus 5 plus 3x minus 2. Pause the recording until this is done. And if we are drawing models here, the first thing that we need to recognize is when I'm subtracting, I can't represent subtraction with a model. So that's why I recognize that subtraction is the same as adding a negative. So 10x plus a negative 5 plus 3x plus a negative 2. Changing that subtraction to adding a negative makes it possible for me to, number one, represent it with a model, and it also makes it commutative. Subtraction is not commutative. You cannot change the order of subtraction. You can, however, change the order of addition. So when we change subtraction to adding a negative, I can now rearrange these things. And without even needing to draw those models, I can see that these pieces, 10x and 3x, are going to combine together. So I'm rearranging it knowing that those are going to combine together. And negative 5 and negative 2, I'm going to rearrange those so those can be combined together. And again, you can do all of this with the models, but for the sake of time, I'm not going to. I have 10x and 3x is equal to 13x plus negative 5 and negative 2 combined to be negative 7. I also had a handful of students who wrote 13x minus 7. Both are equivalent to each other and appropriate. I also had a student who rearranged it completely and wrote negative 7 plus 13x. That is also okay. All of those are options. Now, of these, I have two favorites, and that is these ones that start with the x. We always want to start with the biggest tile or the highest order. This isn't wrong, it's just not necessarily preferred. Okay, so we are going to have a conversation about order of operations. This is something that we mentioned when we were doing our flow maps and trying to solve equations. We had a conversation about order of operations, but it's just as critical here for what we're going to be doing today. So what is the order of operations? Good, I see a couple hands, not enough, so please discuss with your table so that I can see every hand raised. What is the order of operations? Okay, I'm going to be looking for a certain level of precision here, only accepting certain responses. So who is brave enough to give it a try? What is the order of operations? Jaden, get us started. So close. It's not the order that we solve equations, but the order that we look at expressions. Now, when we're looking at an equation, and the reason why we used it in equations is because we were looking at the expression part of the equation and then saying that expression part was built this way and it's equal to this other thing. So it still relates to equations, but it's not the order that we solve them, it's the order that we look at the expressions. Okay, very good. And now, what is the order? We have an acronym that helps us to remember what is that specific order that we do these things. Sam? Gemma. G stands for? Grouping symbols. What are some examples of grouping symbols? Siley. Yep. Parentheses. What others? Danielle? Yes, and there is a fancy word for that. It's called a vinculum. Might be vinculum. I'm going to have to look that one up. But that's really just the dividing line. What other ones, Jaden? Brackets. Later on, you'll be seeing square roots and absolute value symbols, etc. But that's good enough for now. G for grouping symbols. That's the first thing. So if there are grouping symbols, that happened first. And we need to pay attention to what happened first. Gemma, E is next. E is for? Emery, thank you for the hand. Exponents. Exponents are another way of saying, the more mathematically precise way of saying powers. M is next. What does the M remind us of? Not enough hands. We know this. I should see way more hands here. Thank you, Porter. Just multiplication? Yeah, multiplication and its inverse, which is division. And when we're looking at multiplication and division, they happen at the same time in the order of operations, but we go from left to right. That doesn't mean multiplication was written first, so that's on the left. division was written next, so that's on the right. I mean, depending on the expression, it would be left to right, whatever happens first. And lastly, A is for, thank you, Charlie. Yep. Addition and its inverse, which is subtraction. And again, you can make sense of why it's addition and subtraction. When you take a look at this, we had subtraction, which we were able to rewrite as addition. So they are connected, they are related. So addition and subtraction, and again, just like multiplication and division, we do it from left to right. Honestly though, the main thing that we need to focus on today is the G for the grouping symbols. Because what we are doing today is we are modeling expressions with algebra tiles. This is part 2. We're focusing on the distributive property. So our last lesson was focusing on combining like terms, and now we're going to focus on the distributive property. On your pre-assessment, these were some of the absolute lowest questions. We had, with the exception of our warm-up, which you guys all improved on, 27% and 46% got the distribution questions correct. So obviously another skill that we need to refine and practice. So what we're going to do, we're going to model these with algebra tiles again. But before you even start trying to model them, you have to pay attention to that order of operations, which is grouping symbols, exponents, multiplication and division, and then addition and subtraction. So when I look at this expression and I say, hey, are there any grouping symbols? Then that's what we need to model first. I don't care about the 2. I know we see the 2 first, but that's not the part that I'm concerned about. I'm concerned about modeling what's inside of that grouping symbol first. So I need to model 3x plus 5. Go ahead and do that with me. We're going to get out 3 x tiles. And we're going to get out 5 unit tiles. Now that I have my 3 x tiles and my 5 unit tiles, I realize, hey, those are in a group, they're in parentheses, which means I also would like for them to be in a group. So I'm going to put a box around them. You don't need to put parentheses around it necessarily, but I'm going to put a box around it. That's harder to model with your physical algebra tiles. This is how I'm showing that box around it. Now that we have modeled the group, including the grouping symbol, so I've got that box around it, now we can pay attention to what this means. This 2 on the outside really means I have 2 groups of 3x plus 5. So I've modeled the grouping, but now I need to model 2 of those groupings. I am going to cheat because I can duplicate this. You guys don't have that advantage, so I'm going to pause the video and give you guys that extra time that you need to model it with your algebra tiles and then to copy it down onto your paper. I'm going to pause the recording now. All right, now that I've got these 2 groups of 3x and 5 modeled, what do I really have altogether? Siley? Yes. Now I can start looking, instead of paying attention to what is in a group, I can start looking across the groups and see across the groups altogether, I have 6 of those x tiles. And altogether across those groups, I have not just 5, that's 5 in one group, but I have 2 of those groups. I have 10 of those unit tiles, so 6x plus 10. Is this ringing a bell now? Okay, hopefully when I ask you that same pre-assessment question at the end of class, hopefully we can do better. But because we struggled, we're going to take another baby step on this. When we have 2 groups of something, please understand that we have 2 groups of the x and we have 2 groups of the units. And so what that really looks like is we have 2 of the 3x and 2 of the 5. And that's how, eventually, when we are no longer drawing these models, how we get to the 6x. Two groups of 3x is 6x, and two groups of 5 is 10. That's going to be especially important as we start dealing with some negatives in some of the future problems. So please make sure that your paper looks like my screen. Please make sure you've got your models drawn. Please make sure you are showing two groups of 3x and two groups of 5. And then showing that complete simplified answer, 6x plus 10. A note on each one of these. When I give you the directions to simplify an expression, two things need to be happening. Number one, we want to get rid of our parentheses. So when it says final simplified answer, we no longer want there to be parentheses, and just like we did last time, we're combining our like terms. So both things are happening, which sometimes will take multiple steps. The next one, let's go ahead and model this one. You can model it on your paper, you can model it with your physical algebra tiles. It is whatever your preference is. I will be modeling it on the screen. You guys can do this with your groups. I'm not going to talk over or anything. I'm just going to model on the screen while you guys can visit with your groups. Ready, set, go. Yes, it's because I want this to be in the video. That's why it's still recording. Crazy, right? Yes, I know. I'll give you a little bit of time to model because I can cheat and duplicate. You guys have to draw all the extras, so I'll wait just a second. So again, I have x plus 4 in a group, but I have 3 of those groups. That number on the outside tells us how many groups. Let's write that down. We have 3 groups of, and yes, I want this to be part of your notes, 3 groups of x plus 4. Which means I have 3 groups of x, wrong color, and I also have 3 groups of the 4 unit tiles. Which means when I start looking across the groups to see the like things, I can see 3 groups of x means I have 3 x tiles. And 3 groups of 4 means I have 12 unit tiles for 3x plus 12. And how is it going to work when it's subtraction? Now it's 3x minus 1. Really, truly, I hope that you're not overly concerned about this. When I have 3x plus 1, that really, or excuse me, 3x minus 1, that really just means I'm going to have plus a negative 1 tile. So there is my one group, which I then need to duplicate to show that I have 2 of those groups. So I'll give you time to write that down, but I want you to do this first. This isn't just 3x minus 1, this is 3x plus a negative 1. First thing, we're changing that subtraction to adding a negative. If you take the time to make this change in some of these other future problems on the backside, you're not going to make mistakes. Change your subtraction to adding a negative. And then we remember, hey, this means I have 2 groups of 3 x tiles and negative 1 unit tiles. Discuss with your groups. What should we be writing over here? Discuss with your groups, and then I'm going to ask you to share. Remember, we want it to kind of keep that same format, just like we did up here. What should we have here? Ready, set, go. and now come back to me. What should I write over here? What is this going to look like? Thank you for all of these hands. Jamie. Good. Very good. 2 groups of -1. 2 groups of 3x and 2 groups of -1. So now when I'm looking across the groupings to see what all I have, 2 groups of 3x, you can count it up. You can see that there are 6x tiles there. And 2 groups of -1, looking across the groups, you can see we have 2 negative unit tiles. So 6x plus a -2. You can also, just like we change subtraction to adding a negative, if it is your preference, you can change adding a negative back into subtraction for 6x minus 2. Both of these are appropriate. All right, and now we're to the back side. I'm going to let you go ahead and model 4 for practice, but then I want to talk about 5 and 6 and 7 together. Okay, so just model 4. Going to give you about 60 to 90 seconds to do that, and I'm going to pause the recording. All right, take a look at what we have so far. I've got my 3 groups of 2x plus a -6 modeled. I rewrote it as 3 groups of 2x plus a -6. So when I see this parenthesis, a grouping, and then this number on the outside, I'm not thinking of it as 3 parentheses 2x minus 6, I'm thinking of 3 groups of, and then we list the group. So what is it that we have? Again, I want to see it both ways here. Luke, thank you. Good, 3 groups of 2x, and I love how you said that too. Even though I might write 3 parentheses 2x, I love that it was said 3 groups of 2x. Keep going. Yep, plus 3 groups of -6. And again, we wrote it 3 parentheses -6 or 3 times -6, but it said 3 groups of -6, and I love that. And so what is that going to be equal to, Tage?
6x. You can do like the equal opposite of 6x minus 18, but this one it would be 6x plus
Great, great connection. 6x plus a -18, or if you prefer, 6x minus 18 is appropriate. Nicely done. And now the next one shouldn't be an issue if this one wasn't an issue. The only thing that's different is now I'm no longer going to be using the green x tile because I have 3 negative x tiles. So that should be the only real difference, and we should be able to model that one okay. As long as you recognize that it's -3x tiles, you can go ahead and model that one with your groups. We'll pause the recording there. Shouldn't cause us too much trouble. Pause the recording and get this modeled. All right, recognize what's happening here. We're writing this as 2 groups of. I'm actually getting ahead of myself. I see subtraction. So before I start looking at that, inside of that grouping, I see 2 groups of -3x plus a -4. So I have 2 groups of the -3x and of that -4. Here's that model. So what we're going to be seeing here is 2 groups of -3x and 2 groups of -4. This is the reason why it is really important that you change your subtraction to adding a negative. If you change your subtraction to adding a negative, you're always going to be adding. If you don't, then you have to try and figure out, okay, this would be 2 groups of -3x minus 2 groups of 4. Is the result going to be the same? Yeah. But are you going to be that good at keeping track of it? Okay, and that is why I prefer always change your subtraction to adding a negative. And now when I have 2 groups of -3x, that's going to be 6 negative x tiles, or -6x. And 2 groups of -4, that's 8 negative unit tiles, or -8. Which, yes, now that we see that it's adding a negative, now you do have the option of changing that, adding a negative back into subtraction, -6x minus 8, or -6x plus a -8. This is where we start seeing the one of the most missed questions on that pre-assessment. What happens if we just have a negative? Don't worry about the negative first. We'll get there in just a second. Don't worry about the negative first. What should we be worrying about first? What's inside the group? So don't worry about that negative. Will you please just model 2x minus 1? That's all you got to do right now. Model 2x minus 1, which really is going to be 2x plus a negative 1. (2x) and a negative 1 tile. And before, we'd always put that in a group, and then we have to get the right number of groups. But what does this mean when there's just a negative? Discuss with your groups. What are your thoughts? Okay, and now that you've had a chance to discuss with your groups, now come back and tell me, what does this mean? Good. Gabe, I haven't heard from Gabe yet. Great. So in other words, what you're saying right here, what does this symbol mean? It means opposite. So what we have is the opposite of 2x plus a negative 1. This is really easy to model if you'll quickly turn your attention back to me. Here is my x tile. What is the opposite of that? You just flip it over. And so if you have your negative unit tile, what is the opposite of that negative unit tile? You flip it over, and now it's a positive tile. But again, make sure you understand what that means. I need the opposite of a green tile. That's going to be a red one. The opposite of a green tile is going to be red, and the opposite of this red tile is going to be yellow. Let me get those up there. Turning it to its opposite, turning it to its opposite, and turning this to its opposite. So again, what we really have is the opposite of 2x and the opposite of not 1, but negative 1. What is the opposite of 2x? That's negative 2x. What is the opposite of a negative 1? That's a positive 1. And now you can see that your model matches exactly what we have over here. Put it all together. Last one, number 7. Again, don't worry about what we have out here. All that we really need to worry about first is the grouping. Let's create that grouping. 3x minus 4 means 3x plus a negative 4. So 3x and then 4 negative tiles. Okay, I got mine. Hopefully you guys are not too far behind on getting yours modeled. 3x and negative 4. So now, how many of those groupings do we have? We have 2 of them. So we can start by getting that second group up there. Okay, took care of the group, took care of the 2, and now it's time to take care of the opposite, which means I have the opposite of those 2 groups. And I'm going to write that down. This is the opposite of 2 groups of 3x plus a negative 4. So again, everything here, and I'm totally going to cheat on this one too. Everything here is going to change to its opposite. Just like everything here nope, not what I wanted, is going to have to change to its opposite as well. Cheating with technology. So what do I really have? We have the opposite of two groups of 3x and the opposite of two groups of -4. So then we can really start breaking this down. If I have two groups, if I have two groups of 3x, that's 6x, but I have the opposite of that. In other words, -2 times 3x is -6x. And the opposite of two groups of -4. Start with just two groups of -4. Two groups of -4, we saw that model, that was -8. But now when I have the opposite of -8, I end up with a +8. In other words, -2 times -4, a negative times a negative is a positive. All right, that's it for this lesson. I'm going to ask you guys to get cleaned up, and in a second we're going to finish up with a quick poll to see if you can do this on your own without the models. So go ahead and get cleaned up. You can put your papers away, you can put your models away. This is it for the video. Thank you for watching.